Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. In this moment, I would like to explain about sampling. But before that, let me introduce myself first. My name is Siti Maryam. I'm from 5BB class, English Department, State Polytechnic of Sriwijaya. Okay, let's begin. Before we talk more about sampling, that will be better for us to know about definition in research about sampling first. Here, I will give you an explanation about definition in research. In research term, a sample is a group of people, objects, or items that are taken from a larger population for measurement. The sample should be representative of the population to ensure that we can generalize the findings from the research sample to the population as a whole. After we know about definition, next we have to know about the purpose of sampling. I'm sure that you often look at sampling at your book before. But do you know the purpose of sampling? Okay, here I will tell you about the purpose of sampling in research. In research, the purpose of sampling is to draw conclusion about population from samples. We must use inferential statistics to enable us to determine a population's characteristics by directly observing only a portion or sample of the population. We obtain a sample of the population for many reasons as is it usually not practical and almost never economical. So, that's the purpose of sampling in research. If you ever look other sampling at your book, it's maybe have other purpose too. So, be creative to make the purpose of sampling at your book too. Okay, next, we talk about sampling error and non-sampling error, or measurement error. Sampling error can make a sample unrepresentative of its population. Sampling error comprises the differences between the sample and the population that are due solely to the particular participants that have been selected. The main cause of sampling error is chance. That's the error that occurs just because of bad luck. This may result in untypical choices. Unusual units in a population do exist that there's always a possibility that an abnormally large number of them will be chosen. The main protection against this kind of error is to use a large enough sample. Next is non-sampling error or measurement error. A non-sampling error is an error that results solely from the manner in which the observations are made. It can occur whether the total study population or a sample is being used. It may either be produced by participant in the study or be a byproduct of the sample plans and procedures. The simplest example of a non-sampling error is inaccurate measurement due to malfunctioning instrument or pure procedures. This bias in observation can be annoying but very disgusting to the finding of the study. In study observing personal characteristics, unintended error may result from the first one, the manner in which the response is elicited, and the social desirability of the person surveyed, the purpose of the study, the personal bias of the interviewer or survey writer. Next is sampling bias. Sampling bias is tendency to favor the selection of participants that have particular characteristics. Sampling bias is usually the result of a broad sampling claim. The most notable is the bias of non-response when for some reason some participants have no chance of appearing in the sample. For example, internet access for completion of an online questionnaire. There can be two causes of this type of bias. The first one is the wrong study population were selected, and then the study population was all-inclusive, but the poor design of the study introduced the bias. For example, only one group within the study population agreed to participate in the study. Okay, next is selecting the sample. The sampling error may be due to either bias or change. The change component, or sometimes called random error, exists no matter how carefully the selection procedures are implemented. And the only way to minimize change sampling error is to select a sufficiently large sample, where sample size is discussed toward the end of the tutorial. Sampling bias, on the other hand, may be minimized by wise choice of the sampling procedure. Okay, next is types of samples. The convenient samples to research population is chosen out convenience from a population for observation. For example, here, recruiting patients with a particular illness from the support group. The second is purposeful sample. A sample collected from information-rich cases for in-depth study. The size and specific cases depend on the study purpose. And type of purposeful sampling. The first one is extreme and deviant case sampling intensity. Then sampling homogeneous sampling, typical case sampling, stratified purposeful sampling, snowball or chain sampling, theory-based sampling, opportunistic sampling, convenient sampling. These types of samples. Then we continue about sample size. Before deciding how large a sample should be, you have to define your study population, or who you are including and excluding in your study. The question of how large a sample should be is a difficult one. Sample size can be determined by various constraints or funding available, the time constraint, and etc. Sample size depend on: the first one is the type of data analysis to be performed, the desired precision of the estimates one wishes to achieve, the kind and number of comparisons that will be made, the number of variables that have to be examined easily, and then how heterogeneous the sample's population is. Deciding on a sample size for qualitative inquiry can be even more difficult than quantitative because there are no divine rules to be followed. It will depend on what you want to know, the purpose of the inquiry, what is at stake, what will be useful, what will have credibility, and what can be done with available time and resources. You can choose to study one specific phenomenon in depth with a smaller sample size or a bigger sample size when seeking breadth. It's sample size. Okay? Next is sample size determination. There are several approaches to determining your sample size, and the most popular of these is the one that studies the power of a test of hypothesis. Power calculation, therefore, to undertake this approach, the researcher must be clear what the researcher is looking at and what's hoped to find at the end of the study. This research must have a hypothesis. For project other than small-scale project, it is advisable to employ the skills of a statistician to help you with your power calculation. This will ensure that your sample size is large enough to ensure that your results are statistically significant, but not so big that you could have achieved the same result with a much smaller size. For small-scale studies, once you have the information required to do your power calculation, there are computer software packages are available free on the web that you use to determine your sample size. Okay, friends, I think that's all. Thank you very much for your nice attention. Assalamualaikum warahmatullahi wabarakatuh. Goodbye.